Hey everyone, today we're gonna be doing a lead code question which is to sort the array by increasing frequency. So in this question, we are given an integer array nums. We need to sort this array based on the increasing order of their frequency of a value. So suppose this is array, we have this particular element. So you can see the frequency of 1 is twice, for 2 it's thrice, and for 3 is once. So they are saying, okay, the element having more frequency, less frequency should come first. So we need to sort this frequency in the increasing order. So 3 having 1 frequency, it came first. 1 is having 2 frequency, it came second. 2 is having 3 frequency, it came last at last. So if I say, okay, they have another condition. If the frequency of a multiple element, you can say this multiple value, this means for this case, the 2 is also having 2 frequency, 3 is also having 2 frequency. In this order, in this case, like if the frequency value, like for any value, the frequency is same, then at the time, like we need to sort this particular array in based on their magnitude. So whichever element is larger, it should come first. So you can say 3 is coming first, then 2. And at last we need to return the array. Let's see the constant. They are saying the length of the array can range from 1 to 100, and the number inside that array can range from -100 to 100. So let's take the example and let's see like how we can do this question. So we have this particular nums. So I can have this nums array. Here in this array, I have some element. Okay, 1, again 1, 2, 2, 2, and 3. So I have taken the first example itself. Now you can see like if I say okay normal sorting, how normal sorting works. So we might be taking two element. I will be comparing these two. Okay, I might be comparing this with this. Again, I will be comparing this with this. So whenever I need to do the sorting in the increasing order, I will be replacing the smaller value in the first place. So if I say I compare this with this, I compare this with this. So for now it's based on the sorted order. But what if like it was 3, 2, 1, or you can say 3, 1, and 2. Whenever I do the sorting, I compare these two values. So I'll say, okay, when I compare 3 with 1, 1 was lesser. That means I need to replace this value. Like I need to swap this value 1 with 2. So it will become 1, 3, 2. Again, 3 is compared with 2. That means I need to swap this. So at last it will become 3, 1, 2. This is a normal sorting function, how this sorting works. So that means I will be comparing the number with the other number. So by look you can see like okay I've been comparing each number by itself. That means I might be using the n square time complexity. But it's not a case like when we do a sorting, I have multiple approaches or multiple algorithm. If you see like for merge sort or you can say for quick sort, the time complexity is n log n. What we do like we generally divide the array into halves, and we again like in the recursive call you might be dividing this array into two halves. This will be swapped again. This will be sorted in this order. This will be sorted in like for this half it will be again divided in two parts. For this two part, it will be divided into single parts. Again, it will be compared and it will be merged. So that particular case takes n log n time complexity. It means it's way smaller than n square part. Okay, this is a normal sorting approach. How this works. Now for this question, they are saying you need to sort based on the increase like frequency, like increasing order of its frequency. So that means we need to take the frequency of the element. So if I take the frequency, okay, 1 is coming once, again came twice. 2 is coming how many times? 3 times. 3 is coming 3 times. So I might be having some data structure called, we can say a hash map, where I will be storing a frequency. So I can say 1 is coming how many times? 2 times. Similarly, 2 and 3 I have. So 2 is coming how many times? 3 times. And 1 is coming, 3 is coming 1 time. So I have seen, okay, 1 is coming 2 times, 1 is coming 3 times. You can say 1 is coming 2 times, 3 is coming 1 time, and this 2 is coming 3 times. Now, instead of comparing this number, like in the normal sorting, what we do compare of the number. Instead of this, in this particular question, we will be doing a custom sort. So instead of comparing this to number, I will be checking its frequency. So I'll say, okay, just take this number and compare based on its frequency value. So whenever I do the comparison on this two number, I'll say, okay, instead of doing on your number, do the comparison based on your frequency. So I will be taking the frequency of 1, I will be taking a frequency of 2. I will be saying, okay, lesser frequency element should come first. That means 1 should come first before then 2. Similarly, 3 should come before 2 and 1. That means the output of this case will be 3, 1, 1, 2 and 2. Now for the second case, like what if the frequency is common? So let's take this example. So I have that nums array. I have the element like you can say 3, 2, 1, 2 and 3. Okay. Now I might be taking the frequency of this number again. So if I say the frequency is what? For 1 it is coming once, 2 is coming 2 times, 3 is also coming 2 times. Now whenever I do this comparison, okay, I'll say, okay, what is the frequency of 2? It is 2. The frequency of 3 is 2. So whenever frequency is common, that means I need to have the maximum element first based on the second condition in the question. That means 3 should come before 2. I might be swapping this to number. I will be having 3, 2, 1, 2 and 3. Again, I will be doing this comparison with this 2. So I can see like, okay, one is having one frequency and another is two frequency. That means one should definitely come before 2 and 3. So at last it will be looking like 1, 3, 3 and 2, 2. So this is normal approach how it will be working behind the scene. Now one more thing, like if I use any sorting function, suppose this is a sort function like dot sort in most of the languages. Okay, this sort function have one thing like called key, on what basis you need to do the sorting. So I can say like, okay, based on this number, by default it is taking two parameters, like I will take this element and this element, it will be doing the comparison and it will be doing the swapping in the array itself in place. You can pass the attribute as well, okay, based on the, you can say how many prime factor they have, or based on the even and odd, or based on the number of square root they have, or based on the you can say a power or something you have. So for now what we will be doing is based on the frequency we will be calling, what we will be doing. So instead of here this normal key, I will be passing this number and I will be checking the frequency count. So I'll say, okay, in this frequency map, just check the value of x. So what I will be doing, like for this particular number and this particular number, I will be doing the frequency comparison instead of number comparison. Now, if you see it like behind the scene, a normal comparison, like if I wanted to know, okay, I need to have frequency like sorting in the increasing order. Okay, increasing order. That means if I pass A and B, so if I pass A and B in this function, let's say like we have some helper function, or let's take like we might have some function, or I'll say okay, function helper. Here it will be receiving two value A and B. These two value, whenever a comparison is done, these two values passed over here. Now we need to do the sorting in the increasing order for this case. That means I will be comparing A with B. So whenever A is less than B, that means this case is true. We need to return for the increasing order. For decreasing order, I will be checking for A greater than B, or you can say A greater than B. For like increasing order, we will be checking A less than B. For increasing order, A greater than B. Okay, this will be going a smaller element first, then the larger. It will be doing larger element first, then the smaller. Now, uh, if I say this particular case A less than B or A greater than B, in the mathematical form it is written like A minus B. So if I say A minus B, it will be giving me a negative value. Okay, so this will be less than 0. If B is greater, that means A is smaller. I can say like if A is smaller, it will be giving me a negative value. Okay, fine. Whenever it is greater, if I do A plus A minus B, it will be giving me a greater value. So either compiler can return true or false. It can understand either true or false. By default, if you see for Java, Python, and C++, they receive a value negative, positive, and like basically a sorting have been done behind the scene in the two forms. Either it can have a positive value or negative value or zero value. So zero means you have A equals to B. Okay, you can do some other operation on this case. Now, whenever you receive a positive value, that means like you have done sorting for A and B, and here you received A is greater than B, and you wanted to do an increasing order frequency. That means your valid this task is not valid. So if in this part in the function A is greater than B, that means B need to come first. Okay, B should come first. Like B should come before A. If we are doing the sorting on the increasing order, that means whenever we receive a positive value, that means second element should come first. Whenever A minus B is negative, that means A should come first. So what we need, like we need to make the element in the negative order. So like instead of explaining this behind the scene operator, I will be writing the code for it. So by seeing the code, you might get easily what we will be doing. So I might be having some helper function. So I have some function helper. Okay, help helper. I have some value A and B. Okay, I have some value A and B. Now, here what we will be doing, like we will be doing the comparison based on the frequency count. So I might be checking a difference. Okay, so whether it is a negative or positive. So I might be having a difference of a frequency, like okay, the frequency A minus B, frequency B. So if this give me a negative value, that means okay, everything is going fine. That means A should come before B. Whenever this will give me a positive value, that means B need to return first. So directly we can return A minus B from here, like we need to return this part. By default, compiler will understand, okay, if the return element is negative, that means okay, it's fine, A can come before B. Whenever here it is written as a positive value, that means it is saying your order is not good, you need to have B before A. So by default it is written like, you can say simply, you can simply return A minus B. But what we need to do for handling the other case, this particular case, if they having common value. So if I say okay, um, I can say if this difference value is equal to what, 0, or you can simply take this particular thing. Okay, I can say instead of writing over here, I can say okay, for this particular thing, if the frequency value is equal to the other value frequency, you need to return what, B minus A. Okay, return B minus A. That means B should come before A. Else, what you need to return? You can return what? This frequency. Okay, the frequency of A minus frequency of B. That means we need to have this in the increasing order, and this particular means we need to have a frequency in the decreasing order. Okay, now I will be using the same sort function. So I'll say okay, nums dot sort. Okay, nonce.sort key. Here I will be passing what, here now whenever I need to do a comparison based on the two value, by default I cannot use that, so I will be using some function library, like you can use some func tools. From func tool I will be importing what, compare to key. So I will be passing two key as a function. So in the key, I will be using this particular library. You can say method. Here I will be passing that helper function. So here it will be taking this particular, like it will be passing two key over here to this function, and it will be returning me some value. Okay, it will be returning me either positive or negative. So based on that, the number will be getting sorted. Now I can return this thing. You can return nums from here. So if I say return nums, it will be done the sorting based on our requirement. So frequency, okay, we didn't created a frequency over here. So let's create a frequency. So like I can create a frequency directly. I can say okay, frequency. I can take a help of a counter function in the Python. So I can say, okay, here counter function generally do the same thing whenever we need to create a frequency. It will create the frequency based on the key value pair in the dictionary format. Okay, so it will create the same frequency counter. Here we can use this particular thing. Here I can submit this code, and you can say, okay, this particular code runs fine. But now most of the people will say, okay, we have used this particular thing, we are not sure, and this is very abstract thing. Like, okay, I didn't need to use this. It is very complex. So this is what's running behind the scene. We can remove this part. Okay, we can remove this part. Even what we can do, like, okay, instead of this key, I can use simply a tuple sort of thing. So instead of this, I can use a lambda function. Okay, I will be receiving a single value from here. Okay, here I will be returning a pair of what? Frequency of this number x and a negative value of x. That means whenever by default the tuple is compared based on the first value. Okay, whoever having the frequency greater smaller will come first as a normal sorting method. Whenever the frequency is same, it will be transferred to the second thing. So now if we need the element with more frequency to come first, that means it will be taking this minus 2 if I do comparison on 2 and 3. So if minus 2 is coming before minus 3 because 2 is like having smaller like larger magnitude. So here what I can do, I can simply compile this code. Let's see whether it is running fine or not. So it is also running fine. I can submit this code. It is like very Pythonic stuff. You some people say, okay, this is more confusing than the previous one. So basically, it's like you are taking a pair of like the frequency of that number and the negative magnitude of that number to represent, okay, which number is smaller or larger. But in general, instead of this, most people are like good with using of this because it is what running behind the scene of a computer. Okay, you might be receiving a negative or positive value and you will be taking some decision based on that. So yeah, that's all for today's. Thanks for watching.